For the next hour, I'm going to give a couple of lectures. So the first one's going to be about field survey, and then the second one will be about sampling. On your program it says it will be trap nurseries, but it will be sampling. So I want to cover these two topics before we go to the field this afternoon, because the idea is in the field you'll get a chance to actually get some hands-on experience using the tools, doing the sampling techniques that I'm going to talk about this morning. So it's going to be a bit of a change from genetics, so field survey. So the first talk I'll concentrate on survey and try and cover why we need field surveys, how to do them, what protocols to follow, tools that can help us, what to do with data, and then a little bit what we can learn from surveys. So this, I think, will be very familiar to pretty much everybody in this room. You're all, I suspect, doing surveys in some shape or form. So why do we need field surveys? Why are they important? Well, I put up a few list of things here. You could think of other things, I'm sure. So, I mean, really, it's that understanding what's happening in farmer fields, yeah? If you never get out of your office, you never get out of your lab, then you've really got no idea what's happening in the real world. What diseases are present? Where diseases are occurring? How are they spreading over time? Sampling, and that will be the focus for the second talk I'll give. Yeah? If we don't have samples, we can't really understand anything about which pathogen, which pathotypes we're dealing with. Alternate hosts. So today we're going to also see barberry and Mahonia. So they're alternate hosts for wheat stem rust, wheat stripe rust. Look at changes over time. If you do your surveys every year or every season, then you can pick up how things change over time. Hotspots of disease occurrence. That's more what we do with the data once we've collected it. And then also, I mean, I guess probably the most important thing is your surveys give you a good basis, information for then your control activities, mitigation, yeah? So before you start surveys, it's usually a good idea that you put a plan in place, yeah? You should think which diseases are of interest. I mean, that influences, you know, the timing when you would go for surveys, which areas you would go and visit, yeah? I mean, if you're interested in rice diseases, probably going to go and visit a wheat field probably isn't the best idea, yeah? And vice versa. Optimal times. So you all know, you know, different diseases appear at different times, yeah? So if you're interested in yellow rust, then earlier season surveys, probably more critical. Stem rust, it's often later in the season. But also don't forget about, you know, you've heard the green bridge coming up, you know, off seasons. Surveys outside of the main season are also extremely valuable in understanding the epidemiology in terms of carryover of pathogen from one season to another. So if you have the opportunity to do off-season surveys, and it might not be on the crop, yeah? So seeing rust on grass species out of the season, those could be the critical samples that give you an indication you've got something that could be important for the main crop season. So don't ignore doing surveys outside of your main season. You should also think about your routes. Can you cover the main cropping areas? If you can't do it yourself, then can you coordinate with different colleagues in different areas so that you manage to, between you, cover the main areas? And that comes into who needs to be involved. Yeah? If your station is right at the far west of your country, but you know there's an important area in the east, then you should be looking to link up with people in the east who could cover different areas. Participants equipped, yeah? Can they identify the disease? Yeah? Do they have tools? And it might just be a paper survey form, or it might be a tablet, yeah? But have they got what they need to do the survey? Do you have resources, yeah? So think about that before. If you decide kind of the day before you go on a survey, oh, I need a car, and I need it tomorrow, then your boss may well say, well, sorry, no cars available, we don't have any fuel in the vehicle, yeah? So you need to plan, think ahead for your survey. Okay, Rust surveys. So with the BGRI, we put together basically a very simple standardized survey protocol. And we've got people using this in all over the world, 30, 40 countries. And the advantage of that standardized protocol is that we can compare data across all the countries very easily. Representative coverage. So again, we talked about trying to cover the main areas. But you can also think about having standard routes that you cover. So again, that's good if you're comparing differences between seasons. Representative samples. I think that's a really critical one. We'll have a second lecture just on sampling. That's going to give you the key information about the pathogen. Yeah? And that's the only way we're going to get the information about the pathogen. And I'm going to talk later about both live samples, but now increasingly DNA samples can give us useful information. But as Robert pointed out, they're still not a substitute for having live samples that can be worked on in the greenhouse. Accurate data, processing the samples in the right way, and I'll cover that more in the next talk. And also timeliness of reporting data. If the data just sits there for 9 months, 10 months, then it's not much use. Certainly if you want to inform control activities. Yeah? You have to get that information to the right people in a timely way. So the protocol that we use with the BGRI, it's, simply visiting a field location. All the data that's been collected, it's georeferenced, so with a GPS. So it can be a handheld GPS, or it can be a GPS in a tablet or in a smartphone. But that location data is really important. So a typical procedure would be you'd arrive at a field site, you'd record the GPS location, you would do the survey obviously for rust in the field, you'd record the information either on paper or in electronic form, collect a sample if it's appropriate, and then go on to your next field survey site. And usually that would be something like 10, 20 kilometers. But it varies depending on how extensive your wheat areas are. But that's basically, standard procedure. And I'm pretty sure most of you are very familiar with this. So technology options for survey. So I guess the traditional way would be a standardized paper form with a handheld GPS. So you go out in the field, you can record the location, you can record the disease information that you see. Now we have options, different options, smartphones, tablets, where basically you can just record the same information, the location and the disease information, but you can just do it electronically. And we'll look at both options today and probably also on Saturday as Sunday as well. So, I mean, there some of the tools that are available to us: GPS, paper, smartphones, tablet, and I don't know if I don't see Ananth here, but with Satguru, they've developed the app for tablets and also smartphones that allows you to field record. So they're useful tools. The survey form, we put this together a long time ago at a meeting we had, one of the early meetings but in Ethiopia. It was tested in the field and it's evolved. It's got simpler, hopefully easier to use. I mean, it's about as simple as you can possibly make it. The GPS location, I'll sort of keep hammering this point. That's critical, yeah? Having that georeference into all the data, it's really critical, especially in terms of the data analysis and transmitting information to people, yeah? So really georeference your data. If you want to get copies of the form, there's the web link there. It's online. You can just download the PDF and print it off. So it's accessible to everybody. It's really simple, but it works. It's given us a lot of useful information in a very, very easy way and covering a very large geographical area. So for those of you who have not worked with using GPS, just a little bit of information about these. So they're readily available. They're increasingly cheap in price. You'd maybe pay, I don't know, less than $100 for a GPS unit. They'll work anywhere in the world. The handheld units, they'll give you an accuracy of plus or minus 4 or 5 meters, yeah? But that's good enough for us. You don't need centimeter accuracy for a disease survey, yeah? It's fine. Elevation, there's a bit more kind of error in the elevation, but again, it still tells you if you're in a lowland area, a mid-altitude, yeah? I mean, it's good enough for what we need out of the information. You need a clear view of the sky, so you would struggle if you were trying to use it in this room because the signal from the satellites is being blocked by the buildings. It can happen if you're in the middle of a very dense forest, yeah, but it'd be unusual if you're surveying, maybe barberry, but wheat you're not usually finding in those situations. They'll work 24 hours a day, so it's not like the system only works during office hours. So any time and basically any weather conditions they would work in. You only have to pay for the receiver. The way the system works, there's 21 satellites that are in orbit. They're continually transmitting the signal. There's no cost. You don't have to buy a subscription to receive the signal. It's available so long as you've got the receiver. In terms of using these, I mean, they're really, really simple. I mean, it's literally a 1, 2, 3 process. Yeah? So you get to your field site, you switch it on. And I'm just using a very common model of GPS here. I mean, there are different models, but basically they all work in the same way. You'd switch it on. You'd wait until it's received the satellite signal, yeah? So you need to get signals from at least 4 of those 21 satellites if you're going to get a location, a latitude, a longitude, and an elevation. Yeah? So depending on if you've got a GPS unit, so if I had one from Africa, which I do, and I've just suddenly got on a plane and I've come all the way here to Nepal, When I first get to the field, it'll take it a little bit of time just to work out it's in a totally different part of the world. So I might have to wait 10 minutes before it actually receives the signals. But once you've used it in a location, so here in Nepal, if I go to the next field within, I don't know, less than a minute, it would have received the signals typically. So if you move long distance, just don't worry, you would have to wait a little bit. And it's just calibrating itself. It's just working out, okay, where am I in the world? So once you've got the signals from the satellites, then you'll see information that it will be ready to navigate. And it will give you an accuracy value. This one's in feet, yeah, US system, but it'll say your accuracy is 4 meters, 5 meters, yeah. So as soon as you get that information, you're good to record the location. So simply the third step then is you just, press the enter button and it'll record the information, and that's all you need, yeah? The elevation, the latitude and the longitude. So that you would record. If you're using paper, that information would go onto your paper form. If it's electronic, it's in the system. It'll be stored. You could say OK and it will store it into your GPS. And usually they come with a cable you could connect to your computer, so you could transfer data from the GPS to your computer. But it's really simple, I mean, using these. So how many have used the GPS? Yeah, most of you, yeah, many of you. And we'll use them today and during the course.